Hey guys, welcome to my channel and I'm back again with another really interesting video. And before I start with this video guys, I want to ask you guys two questions. First is, are you a software engineer who wants to explore generative AI and new innovative tech but actually do not have the money to invest into something like a billing subscription for OpenAI? And second question is, are you a software engineer who does want to play with all this stuff on your local laptops, but your laptop doesn't even have a GPU or the power to actually run these models? And if the answer to both these questions is yes, then you guys are in for a treat, because today I'm going to introduce you to something called as Llama Cpp. And Llama Cpp is what that can enable you to use generative AI models on a CPU based machine without paying anything to actually a billing subscription. So I hope you guys are excited about that, and if you are, then without wasting any time further, let's get started. So first thing first guys, what is Llama Cpp? So Llama Cpp is basically a module that is given to us which can run any generative AI models, or I can say that it serves as an inference for generative AI models. By inference, I mean it can use those AI models and make them do predictions for us, but without using any higher power on our machine or higher memory or something like that. They are able to run on a 4-bit integer quantization, which basically enables them to run on even a smaller machine which only has a CPU. Okay, and to use Llama Cpp, we have to use a Python module called as Llama Cpp Python. So Llama Cpp Python is basically a module that you install on your machine. That is a binding for Llama Cpp. So if you use this module on your machine and use the classes of this module to load your generative AI models, then basically you can use them in your CPU based machines as well. And the good thing is that with Llama Cpp, you can use gguf model files. Now, you might ask me, what are these gguf model files? So guys, gguf model files are basically, a different compilation of your usual generative AI models. And the good thing is that you can find these model files in Hugging Face. So if I just click on this example link, which is actually a Llama2 generative AI model that has been tuned on 7 billion parameters. So you can find the gguf file of this particular model on Hugging Face. And the good thing is that you can go to files and versions, and using this small download button, you can download the entire model on your machine, and it's like 2 to 3 GB, and if you want a better model, then you can also download the 7 GB one. So, but the thing is that once you download this model on your local machine, you can use it with Llama Cpp. So, this solves your two problems. First is that you can run it on your laptop, which doesn't even have a GPU, it only has a CPU. And the second is that you are getting the model for free. You are not paying for any billing subscription to OpenAI or any other company to actually use the model. So now that we know how Llama Cpp works and we also know how it solves our problems, it is time to actually get our hands dirty and do some sort of installation. Now for me guys, I have already installed this on my machine, and I can actually show you my Visual Studio very quickly. And you can see that on my Visual Studio, I have got this notebook that is already doing the Llama Cpp stuff. But for the time being, you can just ignore that, and I can just open the terminal for you and see and show you how I actually install it. So to install it guys on your machine, you just have to do one single command, that is pip install Llama Cpp Python. Okay, that is the only command that you need to do. Now if I hit enter, you will see that it might say to me that the requirement is already satisfied, because I have already installed it, and you can see that it works, right? However, for some of you guys, this command is not going to work. And the reason is that you are using Windows. And so just to tell you that there are different ways to install Llama Cpp Python based upon your operating system. So let me first discuss those for you one by one, or operating system by operating system. So first thing is, like, say if you just have a CPU and you have like a bash machine, or a like a simple Linux machine, you can just use pip install Llama Cpp Python. Just remember guys, that if you are having a Ubuntu machine or if you are having a Linux machine, you must have GCC package, which is the C++ compiler. So if you just search online on Google like how to have the C++ compiler on your Linux machine, you will get to know, and you can just install. It's basically just sudo apt-get install GCC+. Okay, I don't have a Linux machine or a Ubuntu machine, so I can't demo it to you, but I will definitely show you the Windows part. But once you have your C++ compiler, just run pip install Llama Cpp Python and it's going to install it for you. The second is that, let's say if you don't have a CPU but you actually have a GPU. So you have a better machine. You have a CPU and you have a GPU. So if you do have a GPU, then Llama Cpp can work much faster on your machine. For that, you can use this, you can set these environment variables. So if you want to install using GPU, then you can use OpenBlast, CuBlast or CBlast. And to do this, just set these two variables, cmake args dllama qblast on and force cmake equals to 1. Basically it's going to force the compilation again, and then pip install Llama Cpp Python. Now to set these environment variables, the way I have shown here could be different for your operating system. For example, in case of Windows, on your command prompt you usually use like set command. So set cmake args is equals to this and set force cmake equals to 1. But if you are using a bash file or if you are using a Linux machine, then this command might work for you. Okay. But just remember that you need to set these two environment variables if you are using GPU. The next thing is, if you don't have a Linux machine, if you have like a MacBook or Apple machine, then you have to install it with Metal. So for that you need to do cmake args dllama metal on force cmake equals to 1 pip install Llama Cpp Python. Now you guys might be confused that you might not be able to remember all these commands. So what I'm gonna do guys, I'm gonna actually show you a link here which I will also put in the description below. This is the official Llama Cpp Python documentation, and you will find all the installation here. So you can see it has got installation with Metal, with GPU, with CPU, and even it has got some Windows instructions as well. However, they didn't work well with me, but I will I will try to guide you how I did it. Okay, so now that we have the installation discussed for Linux and Mac, it is time for me to demo you how I actually did it for Windows. So for Windows guys, you have to first of all install Visual Studio in your system. So I already have Visual Studio in my system, and once you install Visual Studio, you will actually install it via Visual Studio installer. So just go to your start, and once you have it, you just type Visual Studio and you will find Visual Studio installer. And once you click on Visual Studio installer, you will see it like this. Okay, so if you have just installed Visual Studio in your system, if you have already installed it, find the installer, click on modify. But if you have not yet installed it and you have first downloaded it, while you are installing it, you will get this page by default. But when you get the installer page, just click on modify, and what you need to do is select something called as C++ desktop environment. So you can see it says desktop development with C++. I have just checked it, and once you checked it, then you go install while downloading, and this is going to have a next button for you or install button for you. You click that button and it will start installing the C++ compiler tools. Okay, so this is what I did to first make my Windows environment compatible with C++ compilation. Okay, and once my Windows environment was compatible with C++ compilation, then I just did pip install Llama Cpp Python, and that was it. I don't have a GPU on my machine, guys. That's why I didn't do those environment variables. I didn't set them. But the thing is that if you do have a GPU, you can use those variables, and you can use these commands for Windows: set for CMake1 and set CMake args the Llama QBlast on. And then they simply do pip install Llama Cpp Python. It's gonna do the job for you. Okay. So now we are through and through with installation. So I hope you guys are a little bit familiar with it now. And I'm pretty sure it's going to work for you. But if you do have any issues, do first check the Llama Cpp documentation, or you can definitely write down in the comment section below, and we can all as a community try to figure it out. Okay. So now the installation is complete, and it is time to actually see the magic. So you can see on my machine, I am, although I did advertise to you that you can use it on your local and your laptop, but I'm still running this example today on Kaggle. I will show you the example already ran on my local machine in my Visual Studio later. But let's now, I want to make these things, very quick. So that's why I will show you by Kaggle, because Kaggle has, it just provides a little bit faster environment than my local machine, which is just a 8 GB machine. So it's not that fast. Okay. However, if you do want to explore it, it definitely works on your system. So the first part is just pip install in Kaggle, that you don't have to worry about because we have already done it. Now let's create a code. Okay, just ignore the CTransformers for now. I'm going to create these two files. Okay. So now we have installed the Llama Cpp package. It is time to get some imports. So what we are first going to import? So the most important thing in Llama Cpp is to import this particular class called as Llama Cpp. Okay. So as I told you, Llama Cpp is an inference for your generative AI models. So basically you need a Llama Cpp class to load your generative AI models to make predictions. Okay. Sort of a binding. So definitely you need this class. So that's why I'm importing it. Once you have imported this class, then it's pretty straightforward. You just need, the regular things that you are using in your LangChain. So one is obviously prompt template, and then another thing that I'm going to use here is called as a callback manager. Okay. So there are two imports that I did. One is callback manager, and one is streaming std out callback manager. Now one thing I want to make it very clear, guys, that callback manager has nothing to do with Llama Cpp as such, like it's not strictly bound to it. This is just for an example. What does callback manager do? So basically once you do a prediction, then what's going to happen is that the output of that prediction is going to be displayed to the user, right? So callback manager gives it a little bit better way to display your output. And that's what we are going to do here, that we want to stream the output to ourselves so that it seems to us like when I ask for a prediction, somebody is actually, chatting with me or typing the words one by one. So just to make that effect, I'm using a callback manager. But there are different callback managers, so you can definitely explore with it. But that's not something we want to, go into too much depth. So just explain it. Just understand it in this way, that callback manager is trying to format your output and showing your output to you, but in a better way. Okay. So now we have our imports. So I'm just gonna click on run, and now we have our import sorted. So what I'm going to do next is just I'm going to create a template, and the template basically says ask me a question, and whatever question is asked of me, I am going to answer it in a step-by-step manner. So how I reach the answer, I am going to show you in different steps. And then there is the prompt template, the input variable is the question. Pretty basic stuff. If you guys have been following my videos, you pretty much already know about it. Or you can definitely check it out. No worries in that. Now I am going to import my, instantiate my Llama Cpp portal. And this is something that you need to understand. I'm not going to show you the CTransformers part yet because it's a different thing, but we'll get to it in the end of the video. Okay. So now let's create a Llama Cpp object, and you can see that when I try to call the constructor of the class Llama Cpp, I'm passing some variables in it. Okay. Let's look at the first variable. The first variable is called as model path. So what is the model path? Pretty straightforward, guys. I showed you that you go to Hugging Face and you download the model. So wherever your model is downloaded, that is the path, that is the model path. Okay. So now you might say that, oh, I'm running it on, not on my local, I'm running this on Kaggle. So where do I get the model path? So if you click on this side arrow here, guys, in your Kaggle notebooks, you do get an option to add your own data, or you can add your own model. So I have uploaded this model. So I basically downloaded this model and I uploaded this model as a Kaggle data set. And once I have that, then once you click on add data, you will search your own data sets. So one of my data sets is the one which I created, and I uploaded my Llama2 model into it. And when you click on this plus button, it basically adds the model as a data to your notebook. Okay. And now if I expand it, this model directory, this data set directory, you will see that my model is downloaded here. Now if I just click on the file path and I just try to paste it here, you will see that this is the exact same path, which is the path of my model that I have mentioned here. Okay. A little bit of extra step if you are doing it in Kaggle, but if you just want to play around and you want to see some quick results, I think Kaggle is a really good way. And that's why I do most of my videos with Kaggle. But yeah, so that's how I got the model path. I downloaded it, I uploaded it in the data set, I added the data set in my notebook, and I just copied the path of that model and pasted it here. Simple. Okay. It's much more simpler when you have the model on your local laptop, but we'll see that as well. Temperature, just same as that, as you get temperature in OpenAI. The higher the temperature value is, the more generic it is. The lower the value is, the more precise it is. Max token is something like how much tokens you're expecting in your answer. So maximum tokens. Top V1 is basically out of multiple prediction, which prediction is it going to show. So I'm going to say that out of multiple prediction, I want to see the first top one. Callback manager. So callback manager is the callback manager that we didn't create. So let me first create an object of callback manager, because this is going to fail. So as I told you guys, that callback manager is nothing but some way to display your output, and if you want to use it in some way, definitely you can use it. So this is the object of callback manager. That's what I have passed here in my Llama Cpp constructor. Verbose equals to true. So there are two benefits of verbose. First of all, verbose will show you on your console what is the model thinking, like which steps the model took and what were the intermediate answers that led to the final answer. That's what verbose will show you. And another thing is that if you are using a callback manager and you want to format your output in a certain way, if you set the verbose to true, verbose will take an entire output, all the print statements, give it to callback manager, and then callback manager will show it to the user in a pretty way. Okay. So yeah, there you go. Now we have our callback manager, and we also created our Llama Cpp object. Now I run this code, and you can see once I run this code, it printed a lot of things. So what is it printing? First of all, let me collapse this. What this is printing is, guys, it is printing the variables, the parameters the model is trained on. Okay, a lot of parameters this model has. And you can see that some of the parameters are printed here. In fact, many are printed here. But the most important one, which you might need in future, is something called as n_ctx, which is the parameter that we did not set, but it's by default value to 512. So this is a very important parameter, guys. And if you want to set this parameter, you can just go to your Llama Cpp object, and you can just set the value to by default it's 512. You can set it to 1024, whatever. Okay, now you obviously have this question that what this parameter is and why I didn't set it. Why I didn't set it, guys, is because this is just a POC, just an example that I want to show you, so I don't want to complicate it, and I don't want to take too much of your time because you only have a certain amount to spend on this video. But what this parameter basically means, guys, that NCTX basically means the number of context tokens that you want to provide to your model. What is a context token? So guys, let me show you the template which we created, right? So this is the template. Now this thing which says let's work this out in step by step to be sure we have the right answer and combined with our question. So this entire text is actually a context to your model, because this is the context that it has in its mind. This is the background story it has, and then it is answering the question on the basis of that background information, that knowledge. So initially my context token is 5112. Well, let's say if I take this text and I create it like a 8-line paragraph or something, So if I create it like a 8-line paragraph, then this won't be enough in 512 tokens. This context now needs more tokens so that it can be fed to your generative AI model, right? Otherwise, what's going to happen is you will get an error stating that, oh, this context is too big for the total number of tokens associated with the model. So either you increase the token or you decrease the context. So that's the answer that you're going to get. So that's the thing, guys. That is the main thing what the n_CTX does. And if you want to improve your model, if you want to give it a better context, then it is must for you to play with this parameter, increase it, decrease it as per your choice. But I wanted to show this to you so that you are aware what this is, and if you are getting that context token error, what parameter you have to modify. That's n_CTX. Okay, so now my model is created and it is time to actually ask my model a question. So today, guys, we are going to actually ask my model a question that who is Mr. Beast. So Mr. Beast, as you guys might all know that I am a YouTuber and I am a big fan of him. Let's see what LlamaCpp wants to say about that. Not LlamaCpp, the Llama2 7 billion parameter model. And you can see, guys, that my callback manager is printing this very nicely, word after word, just like somebody is chatting with me, and it is saying me that if you watch a lot of YouTube, especially around the holidays, then surely you have heard of Mr. Beast. And not only that, it is quoting me a YouTube video as well. I'm not gonna play this video because of copyright, but you can see that how good the Llama Cpp is with a Llama 2 model. So it's giving me the right answer that Mr. Beast is a YouTuber who makes videos based around random acts of kindness, like paying bills of people in need or helping out friends with large projects. And I think it's great that his YouTube channels are getting so big, but I don't know much about him beyond his channel. Okay, so he doesn't know much about it, let's say, but now he is, this model is making up questions like what could be the other questions about him. Who is he? Where is he from? Etc. etc. But you can see, guys, that it is pretty good. It's not like exactly like OpenAI. I would definitely say OpenAI is still much better in the race. But if you don't have any budget, if you just have like a CPU based machine, if you don't want to invest into any billing subscriptions, it's pretty great. You can use a Hugging Face model. Just push it into Llama Cpp, and Llama Cpp will make sure that it runs the model and does the prediction for you. Okay, so there you go, guys. You can see that it is still running, but it is probably still answering. And in the answer, it finally does say that his actual name is Jimmy Donaldson. He's from Greenville, North Carolina, as a YouTuber, and he does philanthropy videos. So he's like giving me like a paragraph of answers that it thinks that should be it. We can also see in this case that the answer it has printed is in the end. Before the answer, it printed the steps it took to actually reach that answer. So it seems like that somebody is there who is thinking. So for example, like you are a human and you are thinking that, oh, I do watch a lot of videos. I've seen Mr. Beast in that holiday video. I think his channels are good, and etc. etc. If I want to know more about him, what questions I'm gonna ask him, and this and this. And finally, when I have got all this back and forth thing, all this thinking going on, I finally reach my answer. And that is the answer that it has printed here. And who is Mr. Beast? His actual name, Jimmy Donaldson, his Wikipedia age, and a few more details about him. It's pretty much, it's printing a lot, I would say. But yeah, let it print. But what I wanted to show you, I think I was able to show you. Okay. So while it's still printing it, let it go, and I will show you the same notebook. Okay, I think it's finished. So you can see that's the entire answer, and these are some of the loading times that is shown, and it like prints the entire answer again in an HTML page if you want to render it. Okay. Now I will show you the entire same thing, but that when I ran it on my laptop in a Visual Studio. So let me just simply do this. So you can see this is my notebook, right? So I did the same imports. I made the same template. I created the same fallback manager, and this is the Llama Cpp for Kaggle. But in my case, this model was right here where my notebook was. So the model path is // and the model name, because it's in the same directory. So I just put the same model name, almost gave the same same parameters, and it prints the model parameters just like it was printing on Kaggle. The same question, who is Mr. Beast? The answer is not the exact same answer, but it's similarly same like this, that he's a YouTube channel created by Jimmy Donaldson. It has 25 million subscribers and 8 million views as of March 2022. And there you go, guys. I was able to run this entire thing on my local machine. I was able to run it on my laptop, which only has 8 GB of RAM and it does not have a GPU. However, I must say this, that the reason I did the demo on Kaggle is because Kaggle is still much faster in processing speed, because obviously it's server, and my local machine was much slower. So I didn't do the demo, but I wanted to show you that I did run it and it worked. Okay. Now you guys must be wondering that in the beginning you were able to see something called a CTransformer. So what is that, and why was I saying that let's discuss it later? So CTransformers is also a library, guys, which is similar to Llama Cpp. Okay, let me go back to that. Okay, yeah, there you go. So CTransformers is also a library, guys, which is similar like Llama Cpp. But CTransformers was previously used, and now mostly people use Llama Cpp because Llama Cpp is providing much better latency than CTransformers. But CTransformers does the same thing. It takes your pre-trained model from Hugging Face, and it basically does quantization with it, so you can run that model, make predictions on your CPU based machines. You don't have to have a GPU. Okay, so you can see here the same thing was people install CTransformers. You can use the latest version, and then what I did was from CTransformers import auto model for casual LLM. There are other CTransformers as well, other casual LLM models as well, that also you can explore. But it's pretty straightforward. I would just take the model from pre-trained, pass the exact same model path that I passed in Llama Cpp, the model file name, the model type, the temperature, and that's it. The last thing was I just passed the question into my model, and the question was the AI is going to, and that's it. The C transformer model has to complete the sentence. Okay, sorry, the Llama model from C transformers has to complete the sentence, and you can see that it has printed an entire paragraph about what AI is going to do. Okay, so AI is going to change the world, blah 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 blah. But why I didn't demo it to you guys? Because the latency of C transformers is much higher than Llama Cpp. So that's why, even though you can see Llama Cpp just starts printing within a second, C transformer took some time to print the entire output. So that's why I didn't demo it to you. But this is also another way you can use free of cost models on your CPU based machines. Okay. So that was the video, guys. If you guys have any questions, comments, suggestions regarding this video, please do write down in the comment section below. If you have not yet subscribed to my channel, then please do subscribe to my channel. Hit the bell icon for future notifications of more such programming and coding related videos. If you do like this video, guys, then please do not forget to like this video and share this video with your friends. Thank you so much for watching, guys. Please do write down in the comment section if you explore any of the Llama Cpp things on your local machine and how does it perform. In the end, I would definitely say that OpenAI still holds the highest in all generative AI APIs, because it works the fastest, it does the most accurate results. But if you are on a budget, definitely Llama Cpp is a very good option for you, and you can use latest model like Llama2 with 7 billion parameters. Okay, so thank you so much for watching, guys. I'll see you guys in the next video. Until then, take care.